Hello, my name is Daria, and today we will talk about methods of controlling salinity on your field. Of course, the easiest and probably the most effortless way to know your soil salinity is just ordering a lab report from a laboratory where such tests are a daily routine and where they have all the necessary equipment. And if this is what you want to do, that's great. Just make sure that the lab report you're ordering will contain all necessary indicators for determining soil salinity, such as electrical conductivity test or anion-cation exchange capacity test. And we talked about why those measurements are so important in determining soil salinity in previous videos, so if you haven't checked it out yet, I strongly advise you to do so. But what do you do if you live in a remote place where there's no labs around to help you out? Well, good news for you, you can still determine your soil salinity yourself if you want to. Sure, it won't be a detailed lab report, but you will have a minimum of necessary parameters to make informed decisions on your site about the salinization situation if you have one. The thing is, electrical conductivity test is not only one of the most important tests you can do, but also one of the easiest ones if you are equipped with certain things. And we have already touched on methodology of EC test in the previous video, but today we will go step by step. First and foremost, you will need the conductivity meter itself. Surprise! German Hanna Instruments, for example, is a good and trustworthy brand. And there's also Aspire Instruments and many other brands you can buy it from online within the range of $100 and $200. It, of course, depends on the retailer and the brand, but for example, this conductivity meter on the left with big digital display and remote sensor costs less than $200, and the one in the middle, the conductivity pocket tester, costs a little more than $90. So you can see there is some variety. And both of these meters have the automatic temperature compensation, which will come in handy if you do not wish to spend time on complex calculations of temperature correction. So you can buy whichever you want, whichever sounds most affordable and most reasonable. The next thing you'll need is a calibration solution, which is a solution with a known EC mark. It helps you check your conductivity meter settings in case you need to calibrate it, and it usually costs under $20. Another thing you'll need is distilled water, which is obviously not something very expensive. And lastly, and ideally, you'll need laboratory scales that would measure at least tenths of a gram, which is 1 decimal place. And here, prices vary from $100 to $500. Thus, to conduct a sufficient conductivity test, you will need from $200 to $700, depending on where you're from and what kind of equipment you buy. Is it a lot? Each farmer should decide for themselves, calculating the revenue they get from the harvest and subtracting the expenses. But please remember the cost of a mistake you can make if you don't know your salinization situation. Now, let's imagine you're a farmer who's growing strawberries in Ukraine. Strawberries is a very soil-sensitive plant, and you can get approximately from 22 to 25 tons of strawberries per hectare per season. And this year, in 2024, the cost of strawberries per kilogram in Ukraine was approximately $3. So, multiply the numbers out, and you'll get $66,000 per hectare per season. Now, imagine that you lost 10% of the harvest because you didn't buy the conductivity meter set, and that impacted your decision-making concerning the salinization situation in your field. You lose $6,600 versus $200 or $500 you could spend on conductivity meter set. So now, when we've got the hang of what kind of equipment we can use, let's move to the most important part, methodology. First, we will need to divide our field into sections. The size of a single section will naturally depend on the total size of the field and your agricultural practices, such as intensive and extensive ones. If it's a rain-fed field, then approximately 25-30 hectares per section would be small enough, but if it's a field with irrigation system, then approximately 10 hectares would be much better. However, salinization is a monster that can take various shapes and forms, such as stripes and patches, so we really want to be smart in sectioning our field. The best method would be selecting specific sections according to the productivity zones of your field. To identify the productivity zones, you'll need to look at your cultivated plants or even your weeds present on the field, and see where the plants are lagging behind in development. These are likely to be sections with increased soil salinity, and you will really want to take separate samples from those sections. Another way to section your field is to look at its topography. In this field example, where the drainage system is marked in brown, we see that it's built in a way that addresses the lower parts of the field. With water, soluble salts can move in the soil from higher to lower elevations, and salts usually accumulate in depressed areas of the field. That's why such areas should be sampled in the first place. Let's pretend we have already identified the sections of interest. Now it's time to sample. Ideally, we will need a special soil sampler in order to take average samples of soil, but if you only have a shovel, it can also work, and I will talk about it a little later. First, there are two standard methods of sampling the section: the envelope method and the diagonal method, and both are accurate enough. With the diagonal method, we need to take the subsamples every 30/40 meters from the rectangular's diagonal. Which one it matters not. Soil from each subsample goes into one pail, and then it has to be mixed thoroughly to form the section's full sample. Then we have to take from 300 to 500 grams of soil, put it into a plastic bag, and make sure that we labeled it. For the envelope method, everything stays the same, except for we take the subsamples from the section's corners and its center. Of course, not the little corners of the section, but 10-20 meters away from the edges. If you are sampling the soil, ideally you should use a cutter just like this one on the slide, because it allows you to get a homogeneous sample. But if you don't have a cutter, you can use a dagger. To get a good sample, you should first make a hole in the soil surface with a dagger, and then cut soil vertically to get something like a slice. Now, when we have our samples, we should dry them. In the labs, they use very precise ovens, but we can use any improvised means. In order to know when the soil is ready, we should make sure that no water is evaporating from the sample anymore, and to know that, we should first weigh the sample when we think it's dry enough, then let it sit a little bit more, then weigh it again, and compare the masses to make sure that it does not change anymore. When the soil is ready, we grind it in the mortar, or anything else that looks or functions like a mortar, and let the soil go through the 2mm sieve. Then we mix the soil again and spread it into a thin circle, and pretend it's a pizza that has to be cut into 8 pieces. And we need about 20 grams of soil for our testing, so that will be about 4 grams of soil per either odd or even slice of the pizza. Now, time for the test itself. Here's the procedure. Add 100 milliliters of distilled water to the soil, stir for 3 minutes, leave the mixture for 5 minutes and let the soil settle down. And now we can put the conductivity meter into the liquid. Now you know the basic method for conducting the soil conductivity test. And in the next video, we will talk about what to do if the soil salinity starts to increase. So I will see you soon.